Elizabeth, do you want to take it away?
Am I the organizer to this morning? I mean, the moderator? I thought it was going to be Kathryn Curtis, but I guess she's not here. Okay. Good morning, everybody. Welcome to our session on commuting and residential mobility and climate change effects. I'm really pleased to present, to have this group of people here to present their research today. I'm sure it's going to be a brilliant session. We're going to start first with Jim Elliott. So Jim, take it away.
Here.
Yeah.
All right, can everyone see that? Or a thumbs up from somebody on the panel?
Yeah, it looks good.
Good, okay. Good morning, everyone. Today I'm going to be presenting some research with fellow sociologists Kevin Loughran from Temple University and Phylicia Brown from my own Rice University. And this is research that's forthcoming in the journal Social Problems. And what we're going to be looking at is how the same policy of managed retreat can play out in ways that disproportionately impact or erode the social value of home through community attachments for less privileged urban communities. So when we think about community attachments, oftentimes we think about small island communities off of the coast of Alaska or Louisiana, and that's for good reason. These are real folks wrestling with real problems about how to preserve their community attachments that have been built up over time, both to themselves and to place. And for the rest of us, the question, as we're often told, is not just if that's going to be our challenge as well, but also when. And so we would also point out that it's also a question of where that's going to happen. When we look at the numbers for FEMA funded buyouts across the nation, what we find is that where is increasingly and predominantly in urban areas and not in rural areas. If we look at this graph over time, we find that the central counties of US metro areas actually outnumber the buyouts in more suburban areas by about 6.5 to 1. And they outnumber those in non-metro areas by about 5 to 1. But a funny thing tends to happen when we enter into urban spaces, and that's that the question of community and community attachments for some reason seem to fade a little bit into the background. And for us, we think that's an issue or a challenge, not only ethically, but also analytically. And here's why. Sort of scoping out, the way we think about buyouts is that it's really a balancing act of, no matter where you are, between the social value of home and the economic value of home. And most of the policies and the cost benefit analyses really focus on the economic value. And that economic value is one that's obviously threatened by imminent flooding through increased insurance costs, mitigation costs, and the uncertain policies that can arise and erode demand for housing, and therefore the equity or the price that one can ask. So that's the economic value of home. But of course, there's also the social value of home that builds up over time through ongoing investments and attachments, the people and places, and oftentimes the routines that are in that area and in one's home. So the way we think about retreat, at least from the homeowner's perspective, is that it's really a balancing act. And that balancing act between the social value of home and economic value of home and how you preserve both is not just a question of if one's going to take a buyout, but where that buyout leads once one undergoes that. And so for a lot of folks, we think about the economic value being preserved by the quote unquote fair market price that a government agency or local flood control agency might provide for a home. So what we want to do is focus the spotlight a little bit more on the social value of home and that balancing act. So when we do that, we can think of that social value and those community attachments to place along two basic dimensions. Here along the x-axis, what we have is once someone takes a buyout and resettles, there's the question of attachment to place. How far does the homeowner or the family or the household move from their flood-prone bought-out home? There's also the question of attachment to people. And so we can think of that as the y dimension of this diagram, which is the eventual average distance one resettles from similarly resettled neighbors. That is, people who are resettling through the same program. So these different axes, when you intersect them, can actually help us think about managed retreat as not being one thing, but being maybe four different types of thing. So in the lower left corner, what we have is a type of retreat that we've called collective retreat. And that happens when most of the community members move relatively collectively just a short distance away. And we would say that this best maintains or preserves the social value of community attachments because basically you have the community moving just a little bit away and they're doing that relatively collectively. And so a good example is Valmeyer, Illinois, which moved relatively en masse just a few miles in and up from the banks of the Mississippi after flooding there and maintain their community relatively close by. On the opposite diagonal, we have a situation in which the distance moved from one's home and the distance one ends up from similarly relocating neighbors or community members is relatively high. And we call that individualistic relocation. And it's probably the type of relocation or retreat that least preserves the social value or community attachments because people end up dispersed from one another and relatively far from the place that they once called home. Then on the other diagonals, we have other types of retreat. We have individualistic retreat, where there's a short distance move that ends up sort of having folks resettle relatively farther away from each other. And then there's what we call collective relocation, where there's a more longer distance collective move. And the one that's circled with the red is an example of that collective relocation that's maybe best exemplified by the move of folks from Ile de Jean Charles, 40 or 50 miles up inland, but doing that relatively collectively. So with that background, our research becomes fairly straightforward. We're simply asking, do different types of urban neighborhoods retreat differently under the same locally administered policy? And again, we're entering into urban areas and central areas because that's where a lot of these buyouts are actually happening. So to answer that question, we decided to conduct a case study of Houston, Texas, starting in the central county of Harris County, which is almost contiguous with the boundaries of the city of Houston. And we focus on one urban area because what we want to do is help hold that urban area context constant so that we can focus more deliberately on the differences in resettlement across neighborhood types. And once we're in Harris County makes sense to look at because it's experienced quite a bit of flooding over recent years. It's quite large. And so that large square area means that there are a lot of different watersheds. And what we're looking at are not vacationers who are going to the coast, but these are people who live in these neighborhoods full-time across 15 different watersheds in very, very different and segregated neighborhoods. So in that lower left, you can see the little dots. It's not so legible, but you can see that they're scattered all around this county, which can fit, amazingly enough, the cities of Austin, Boston, Chicago, and others in that space with room to spare. So quite a large area to look at this and use as a test case. So the data that we're going to use to look at the resettlement starts with a list of about 2,300 private homeowners. So we're excluding corporate homeowners and non-developed sites that were bought out between 2000 and 2017, that is before Hurricane Harvey. And then what we do with those records, we have the name, we have the address, we have the price paid for the buyout. And then we use tax records and online databases to locate where it is that the buyout participants subsequently moved. And so through those sources and double checking, we were able to locate 1,782 of those participants, or about 75% of the full population of list pre-Harvey. And when we look at selection bias, we find that there's not a whole lot of difference between those we located and those we didn't locate with respect to the cost of the buyout or their census tract demographic. So feeling pretty good about that. And then what we decided to do is focus just on the participants who stayed within the very, very large Houston's metro area. So that's about 88 or 90% of our sample. And when we look at that, we start with about 92 different census tracts in which buyouts occurred in Harris County. And those are distributed across 39 different community areas, or what we call super neighborhoods, across the 15 watersheds. And then we're going to look at destinations across the 10,000 square mile area of the metro area, which in fact is large enough to be larger than at least 5 states in the US. So with those data collected, that was the hard work. Then we wanted to be relatively straightforward. And so we're just going to fit some basic regression equations. We're going to do that a couple times. One, we're going to use the distance move from address to address, that is from the bought out address to the subsequent address, as our indicator of distance moved or attachment to place. And the second dimension of distance is going to be the median distance one ends up relative to other neighbors who also relocated from the same area through the same program. So with that, what we're going to do is fit some basic regression equations and see how these elements of community attachment play out across different neighborhoods. And for those neighborhoods, we're going to use a couple different indicators. For class or economic status, we're going to use the average or mean price paid for a buyout house in that particular neighborhood area. And then for racial privilege or status, we're just going to use a simple indicator of percent white in the census tract in which that buyout took place. So what do we find? These are results rather than show you the regression coefficients, which I'm happy to pass along if anybody's interested in the full paper. But here's the first finding we have, graphing those regression results. We find that as our average price of a buyout in your neighborhood increases, the distance moved decreases. So that goes down over time. This allows more privileged, economically privileged neighborhoods to actually maintain that attachment to place. They're moving shorter distances so the people who stay behind in those bought out neighborhoods can still have connections to those who left and vice versa. When we shift the indicator to percent white in the track or racial privilege, we've seen the same basic trend. So again, those neighborhoods in which buyouts happen that are whiter tend to be better able to preserve the spatial and thus we think social value of their community attachments to place. Then what we do is shift to the other dimension of distance. And this is distance from similarly located neighbors. This is after the buyout move by the average price of the buyout in the community from which they came. So again, we see this strong downward slope. So as average price for the buyout increases in a neighborhood, the distance from other neighbors who did the same thing declines, thereby maintaining or preserving the potential for social value and community attachments to people. When we shift to racial privileges, we see the same thing. As the percent white in a buyout tract increases in an urban neighborhood, the distance from other neighbors doing the same type of movement declines or decreases, better allowing them to maintain that social attachment with people. So what we can do now is go back to our typology, because our question is what types of retreat happen in different types of neighborhoods. So what we've done here is just simply taken that original analytical sort of crosshatch and we've created a demeaned graph. So in a demeaned graph, what happens is that we basically on the y-axis, and I can't see those values are because it's hidden, but the distance move average, I think is 11.4 miles. And so that's the 0 on the x-axis. And the average distance from similarly located neighbors is about 14.2 miles. So that becomes d-mean 0 on the y-axis. So we can then use our regression results from the prior slides that I mentioned and begin to plot different types of predicted values for different types of urban neighborhoods. So when we do that, we can first start with the more privileged neighborhoods. So these are both within our sample distribution. So we can look at neighborhoods where the average buyout price is about $280,000. We find that the negative values mean that they're both settling, shorter distances from one another than the mean. So those negative values are deviations in the sort of the negative direction from those means. And so that leaves them in the quadrant or type of collective retreat. Same basic principle for the 90% white in the tract. So more privileged areas, either racially or economically, tend to end up in this sort of mode of collective retreat. By contrast, when we go ahead and graph the sort of less privileged neighborhoods that are still deeply attached to people and places there and have a social value that they've invested over time, what we see is they end up in the quadrant with the positive values on both dimensions of distance. And so we see more of an individualistic relocation whereby people are ending up farther away from their place of origin or their buyout neighborhood and from each other, thereby basically eroding or discounting the social capital that they had developed there. So in conclusion, we see these different types of retreat occurring in urban neighborhoods. And so the main conclusion is that we can take the same policy that's implemented through colorblind cost-benefit analysis in a way that says, hey, individuals will make decisions about what's best for them. And we see that when we run unequal neighborhoods and homeowners through that same policy, we get different types of retreat for different types of neighborhoods. And we say it's not just different, it's divergent and unequal, because what's happening in the less privileged urban communities, whether that's measured by race or class, is that they have to give up more of their social value. They end up farther away from each other and from their place of origin or their communities, thereby eroding that social capital in those places, as well as the individual social capital they're able to take with them. And so that leaves us with the concern that, this may, if it continues through this policy, leave us with a new and increasing form of environmental injustice, and in a form of environmental injustice that's rooted more in how the policy is designed and plays out than from the flooding itself. Thank you.
Thank you, Jim. Sorry for changing the order at the last second. I was unexpectedly filling into this role. I will be up next, and so I'm just going to get started. Abby, can you share my slides? All right. All right. So thank you for attending today. Climate change will increase the number of highly destructive weather events that are likely to cause residential mobility. This is well understood, especially by people at this meeting, and federal, state, and local governments are taking measures to adapt places to mitigate these impacts. However, as we just saw, often policies favor some sociodemographic groups and disfavor others. And so the aim of my research today is to look at the past data on the past housing and mobility patterns to understand which groups are more vulnerable to disaster-related mobility and how this affects their housing outcomes. Next slide, please. In today's presentation, I'm posing 3 questions that I'll evaluate using a nationally representative survey that's unique in that it asks recent movers about why they moved, including a response option that they moved because of a disaster. So these are the three questions I'm going to ask. And in the interest of time, I'm not gonna say them all here. I'll just add them as I go along. Next slide, please. The most important question in my talk is the second question, which focuses on differences in the probability of disaster-related mobility between demographic groups. And there are three hypotheses within that question that I'm going to evaluate. The first is what I call the random acts hypothesis, which poses that disasters strike randomly and therefore affect residents without regard to their socio-demographic or housing characteristics. And therefore, we shouldn't see any differences in the probability of disaster-related migration between disaster-related movers and non-movers. The competing hypotheses, there are two. One is the protected homeowner hypothesis, which is that homeownership protects people against disaster-related mobility by allowing them access to resources like private and public insurance against disaster losses, as well as the legal right to remain in a disaster-damaged home while they're rebuilding it. If this is true, then we'll see that renters are more likely to be disaster-related movers than homeowners, and also that renters, who in general are 4 to 5 times more mobile than homeowners, would be even more likely to move because of a disaster than they would be to move for any other reason. Another competing hypothesis is the social vulnerability hypothesis, which is really the dominant hypothesis in this field. So there's a great deal of research, mostly case study research, that supports this hypothesis. But case study research often has, or necessarily has, some weaknesses. And two of those weaknesses are that are addressed by the data set that I have, which is nationally representative and has many covariates. So the first weakness is the lack of generalizability. If you are only looking at a single place, you can't necessarily say that what happened in one time and place is what happens in general. And the second weakness is omitted variable bias. In particular, when you don't have many variables and you don't have a multivariate analysis, you may be leaving out key variables that are correlated with the household characteristics or social characteristics of households, and those would artificially increase the magnitude of those household characteristics. So if the social vulnerability hypothesis holds, then we would expect that household characteristics would be statistically significantly associated with disaster-related mobility, even after controlling for the housing unit characteristics and for all of the other characteristics in the model. Next slide, please. I use the American Housing Survey, which is a nationally representative survey of housing stock that is carried out every 2 years. It includes basic questions on household characteristics and housing stock. Between 1997 and 2013, recent movers that are defined as households that moved into a sampled housing unit in the past 2 years, all of those households were asked their reason for move. And during this time, the response option of a disaster was offered to all respondents alongside the more typical reasons for moving. And this provided a consistent methodology for measuring disaster-related mobility. So that's why I was attracted to using this particular data set. The other reasons for moving and alongside disaster-related mobility are the dependent variable in the multinomial logistic regression analysis of mover types that I'm carrying out today. So that in addition to disaster-related mobility, we have other forced mobility, work-related mobility, family and housing-related mobility, and then non-movers. So the first question I posed was, how much of all residential mobility is attributable to disasters? Disasters constitute a range of events that may affect just one or many housing units. So that could be a house fire, but it could also be a hurricane. And we know that hurricanes are disasters that affect large areas and many, many housing units. An especially destructive hurricane season can really affect this predicted probability of being a disaster-related mover, especially in the South and to a lesser extent in the Northeast of the United States. This figure shows the predicted probability of a disaster-related move by region and survey year, holding all other variables at their means. Throughout this period, on average, only about 1 out of 1,000 households moved because of a disaster in the previous 24 months. That may be very low, but that's also something that we should be happy about. While the predicted probability of disaster-related mobility is small, the variability in this figure shows that highly destructive hurricane seasons increased disaster-related mobility in the South and in the most recent period in 2013 in the Northeast. So you can see in 2007, a period that covers the 2005 to 2007 years, Hurricane Katrina, as well as Rita and Wilma, made landfall in the South region. And that's where that really, disaster-related mobility quadrupled to 0.005% or probability, which was a, massive increase. You can see the similar patterns in 2009 when Hurricane Gustav and Ike struck in the South. And then in 2013, you can see the Northeast probability increased after Hurricane Sandy. This variability is what gives me confidence that climate-related events are influencing residential mobility in the United States. And it also gives me confidence that we're really measuring what we think we're measuring. Next slide, please. So our next question asks whether disaster-related movers are different than non-movers. In this model, I'm first testing the random acts hypothesis that disasters strike randomly, and therefore we shouldn't see any difference between disaster-related movers and non-movers, who are the reference group. In this table, you can see that the first column has all of the variables that are controlled in the model, in addition to year and region. And then the second column with a title disaster versus non-mover, that's where we see the results that evaluate this random acts hypothesis. None of the sociodemographic characteristics of households are statistically significant except for race and ethnicity. And there you can see that on average, the odds of being a disaster-related mover are 33% higher for non-Hispanic Black households compared to non-Hispanic white households. And then for Hispanics, the odds of being a disaster-related mover are 38% lower relative to white households. This contrasts with the results for other types of movers. So if you look at the other columns, you see many more statistically significant odds ratios for all of those demographic characteristics like the age of household head and the household type. And so that is interesting because what it suggests is that disaster-related movers are not selected on life course variables, but rather they are selected on race and ethnicity. Race and ethnicity strongly correlates with other socioeconomic statuses that are not measured in this data set. And so that makes us think that, okay, there's a systematic racial pattern in who moves because of a disaster, and that would be inconsistent with the random acts hypothesis and points us to the two competing hypotheses. The last row of this table gives us some evidence about the protected homeowner hypothesis. Here we see that renters are 4 times as likely as homeowners to move because of a disaster. But looking across the row, you can see that the same is true for all other types of movers. In fact, renters' odds of moving for any other reason are actually higher than the odds of moving for a disaster. So next slide. The second part of the protected homeowner hypothesis predicts that renters are more likely to move for disaster-related reasons than other reasons. And so I use the same multinomial logistic regression results where the contrasts are different. I contrast disaster-related movers against each of the other mover types. And on the bottom row of this table, what you see is that the odds that a renter is a disaster-related mover are not statistically significantly different than the odds that a renter moves for another reason. So these results do not support the protected homeowner hypothesis. But given the possibility of confounding of householder characteristics and homeowner status, I decided to interact household characteristics with homeownership. And that's in the next slide, please. So in this interaction model, I only present the results for the contrast between disaster-related movers and non-movers to keep the table legible. And the first column of results shows the main effects of disaster-related mobility versus non-movers, while the second column shows the interaction of each variable with housing tenure. So the main effects column should be interpreted as the odds for homeowners of being a disaster-related mover, while the interaction term shows the odds of being a disaster-related mover for renters. While non-Hispanic Blacks homeowners' odds of being a disaster-related mover are higher than those of non-Hispanic whites, the statistical significance is diminished, as it has for Hispanics as well. So, but the direction of effect is the same as in the previous model. But what we see instead is that the odds of being a disaster-related mover are higher and stronger, more strongly significant for female and male householders who are homeowners compared to married couple homeowners. So in contrast to that, among renters, these female and male-headed households have lower odds of being disaster-related movers. So the interaction model provides support for a more nuanced social vulnerability hypothesis in which the odds of disaster-related mobility are heightened among homeowner households with fewer adults. The relationship to race and ethnicity that we saw in the previous model is likely due to the confounding of race, household type, and home ownership. Homeowners with fewer adults in the household may have lower earnings to cover the cost of recovery and to continue making mortgage payments, which would increase the odds that they would have to move after a disaster. This is a really plausible explanation for why these types of households were more likely to be disaster-related movers. And it is also consistent with my third question, which asks about residential outcomes. And so in here, what I'm looking at is a logistic regression model where we just look at the effect of the reason for moving on the type of, the quality of the housing outcome at the time of the survey. And we find that if disaster-related, well, the hypothesis would be if disaster-related movers are moving because of constrained economic conditions, they're less likely to find satisfactory housing. Indeed, what we find is that looking down each of these columns, disaster-related movers are most likely to say that their housing quality is worse, their neighborhood quality is worse than their previous house and neighborhood, and they are more likely to be living in inadequate housing compared to the reference group, which is people who moved for family and housing related reasons. So this is consistent with the idea of people moving under constrained economic resources and having worse outcomes. So the takeaway from the research is that climate-related disasters are likely to increase residential mobility for socially vulnerable homeowners in particular, and to worsen residential outcomes for any disaster-related movers. Further research on this topic should look more deeply into how homeownership fails to protect low-resource households against disaster-related residential mobility, and to identify policies that would allow them to maximize their housing outcomes if they are indeed forced to move. I'm going to conclude there. I hope I stayed within my time. Thank you very much. Oh, and our next presenter is Kathryn McConnell.
Thanks so much. Does that look all right?
Yep, it looks great.
Okay, great. Thanks so much for having me here today. Really glad to be able to participate in this panel. My name is Kathryn McConnell. I'm a PhD candidate at Yale School of the Environment, where I study environmental sociology. Today, I'll be sharing some preliminary findings from ongoing qualitative research on migration decision-making in households following the 2018 Campfire. As you probably know, the Campfire was one of the most destructive and fatal fires in the country's history, destroying much of the town of Paradise, but also neighboring unincorporated communities of Concow, Magalia, Yankee Hill, and Butte Creek Canyon. To give you a bit of the sense of size, the population of the town of Paradise before the fire was around 26,000 people. But during the fire, the majority of housing stock was destroyed. And by some estimates, around 83% of the population in Paradise was lost in the year following the fire. So for the past few years, I've been conducting interviews with individuals and couples who've either had their homes directly impacted by the Campfire or other individuals who've been involved in the recovery or resettlement process in some way. So the ends shown here are interviews conducted to date, but I'm still continuing this work throughout this summer and fall. So I'm at a juncture where your feedback would be really helpful for this work. Additionally, I want to mention that this work is being conducted in collaboration with California State University's Campfire Oral History Project. It's a really amazing team of folks there that started collecting interviews very quickly after the fire and is creating a larger public record. So many of the interviews that I'm conducting are being added to this larger archive. I've ended up focusing my dissertation work on wildfire impacts largely because they're far less studied in the world of climate migration scholarship, as well as these emerging conversations that we're having around retreat and managed retreat. The interviews I'm conducting are guided by two core research questions. First, I'm trying to tease out and give a bit more texture to the more generalized model that we have from Black et al., which you've probably seen too many times already, but specifically I'm trying to describe what actually happens on the ground within this blue pentagon. So how specifically does an environmental change, in this case the Campfire, interact with these various economic, demographic, social, as well as political drivers? And then second, with this increasing attention in the field shifting towards receiving communities to which climate migrants, if you want to use that word, move, I aim to understand how migrants are actually selecting their destination, what pull factors might bring them there. So this map is created by geographer Peter Hansen at Chico State University, gives you a sense of how widely dispersed campfire survivors were after the fire. And notably, one of the largest clusters outside of California is in the Boise metropolitan region in Idaho, which somewhat serendipitously is where I grew up and where I now live. So much of the work that I've been focused on is talking with folks who moved to Idaho, though I've also been interviewing individuals who moved to Nevada, Oregon, as well as other parts of California. Most of today, I'd like to share some of the migration narratives directly from the folks that I've been interviewing. And I'll start by sharing some of the migration decision-making that surprised me a bit in that it may have been triggered by the fire event, but is motivated largely by factors not directly related to the fire. In many cases, I'm hearing the fire as almost acting as opening a window for a household to make a move that they had already been contemplating prior to the fire. This is not to say that these movers are completely recovered from the fire or that they don't still have unmet needs, but I think that these are really worth discussing as they're a bit different than the narratives of displacement that we hear probably most commonly in public accounts of the fire's impacts. So first, a number of the folks I've spoken with were either on the verge of retirement or were already retired at the time of the fire. They'd been considering moving elsewhere already. For example, Jeff, who's 67 years old, now living in Idaho, says, "That's how we got here. Is I moved up to the Idaho Panhandle National Forest in St. Mary's and did a fire season there as a firefighter for a year. Fell in love with it. That was in 78. Then I went back to California. When Lisa and I got together, I kept talking about how I'd like to move up here when I retired. And when we lost everything, my uncle's going, well, come on up." A number of folks I've spoken with, primarily those who've moved here to Idaho, describe political motivations behind their choice to move and see Idaho as having a political culture that's much more in line with their own. For example, Henry, who's 54, living in Idaho, responds to my question whether politics influenced where he decided to move, says, absolutely, we're conservatives, we're very conservative and God-fearing folk, and we're very concerned that liberal politics will come here. Liberalism has ruined California. It's not a good place to live anymore. Similarly, Jeff, 67, also living in Idaho, says, and I'm not going to Oregon because it's just a wannabe California. Washington's third in the same. We like it here because it's conservative. For folks such as Henry and Jeff, they're actually probably more likely to describe themselves as political refugees rather than use any language around climate refugees. While I hear this a bit less than expected, I do sometimes have campfire survivors describe escaping increased fire risk as a reason for relocating. For example, Linda, who's now living about 3 hours from Paradise on the coast of California, says, we decided that we didn't want to do this anymore. It's a very hot area, it's a very dry area, even though we have our own well. You know, we just decided that we wanted cleaner air because the smoke impact every year from fires was just getting worse. When I asked if her situation now after the fire was any better or worse than before the fire, she says, I think we're in a better situation because I think, you know, there certainly can be a fire anywhere, but Butte Canyon, like I said, is particularly fire prone. Believe me, this is an upgrade in terms of environment. We're enjoying this. Much more common, though, than hearing folks speak about climate or fire stress as a reason to move is hearing them speak about the housing pressures that they already faced. And I think this is a really good example of how a factor can be simultaneously both a push and a pull, sort of blurring the line between voluntary and involuntary mobility. For some, taking insurance payouts or federal money to different, less expensive housing markets has actually improved their financial health and quality of life. For example, Jeff and Mary were both lifelong renters living in Paradise, but through a federal housing authority loan designated specifically for campfire survivors, they were able to purchase a home for the first time. Jeff says, so we didn't have a down payment to buy the house, so the FHA was giving you the loan that you didn't need a down payment for. Mary says it was a very good deal, and our house payment now is less than what we were paying for rent. Jeff says we're buying our own house instead of buying someone else's house. It was brand new and we're the first ones in it. I think that lower housing costs has been a really big pull for many moving from California to Idaho. But that being said, prices here are growing very rapidly, so it's unclear whether the state will continue to be the sort of more affordable housing haven that it has been in the past. But even as some clearly benefited financially from moving and buying in a more affordable housing market and made the choice to do so, a number of folks I've talked with ended up making this choice because they felt like they couldn't financially justify making the trade-off to remain in California. So for example, speaking with a realtor here in the Boise area who's helped resettle more than 10 different families from Paradise, she describes the calculus that many of her clients make. She says also cost, it was a huge one. Like some people, when they got their insurance payout, they still had a mortgage to pay off. So then that only left them with X amount of dollars. And I clarified, so you're paying a mortgage on a house that's non-existent, a house that burned down? She says, yeah. So you pay that off, so you have maybe 200 or 300,000. You could get more in Idaho because if you rebuild in Paradise, that same house you got here would cost $500,000 down there. So I could live in Idaho mortgage-free or build in Paradise and have another mortgage. Though many of the folks I've spoken with describe being glad to be in their new communities and don't necessarily want to return to Paradise or California, I certainly also speak with folks who would like to return and cannot, that we would consider being long-term displaced. For example, Melissa and her husband have been living here in Idaho and started thinking about returning to their property. Melissa says, we actually looked into putting a single wide modular home on the property. We just did this a couple of weeks ago. For a single wide trailer, it was over $100,000. And that's not including everything that the town of Paradise and Butte County are going to charge you to put a trailer on your property. So we just can't afford that. I want to briefly touch on a number of the obstacles that people face in trying to rebuild, just to give you a sense of really how much time, effort, and cost it can take. First of all, it's of course very expensive. And if you're someone who didn't have good insurance or didn't have any insurance, this can be a huge limiting factor in your ability to return and rebuild in place. Of course, many folks living in the area were renters or owned their home but did not keep up insurance on it. So for these, rebuilding resources just are very scarce. Even if you are someone who has the insurance payout to be able to rebuild, finding builders, architects, the folks to actually do the work when there's so much demand can be very difficult. And on top of building the actual house, the fire as well as the subsequent cleanup caused major damage to sort of below ground infrastructure systems, including electric lines and plumbing, which require a lot of updates. There's also costs and logistics associated with getting property lines reestablished and half-burned trees removed from the lot. And finally, the water source in the area was initially contaminated with benzene, as well as other toxins from homes burning. So there's a lot of ongoing concern about contamination and actually safety of moving back. Beyond the logistics of simply rebuilding, which is not simple, there are several larger institutional factors that can also inhibit rebuilding or returning to place. First, many home insurance companies are really rapidly changing their rates to account for updated fire risk assessments, which for many homeowners has led to price increases, and in some cases, insurance companies simply refusing to insure existing homes or homes that would be rebuilt. That's called a non-renewal. An example that someone shared with me is shown here on the right. The state of California has enacted a moratorium against these changes, but in my mind, this is really a looming issue that could have enormous impacts on mobility and housing access. Second, many folks have been involved in lawsuits against PG&E, which is the utility company that was found legally responsible for starting the fire. So many people are actually still waiting to receive any payments and do not have a clear sense of when they will receive that payment or for how much that payment will be. A recent NPR report found that as of this May, less than 0.1% of the $13 billion that's been promised to Campfire survivors has actually been administered. So not having these resources, but believing that they might become available really put some folks in this sort of place of limbo of deciding whether to rebuild or move away permanently. To share some concluding thoughts with the caveat that this research is still ongoing, I'm hearing migration narratives from folks that are more diverse and varied than simply displacement. Certainly there are many people who are displaced by the campfire, but there are also those who are moving for really different reasons related to amenities, housing, and politics, and who would describe their situation now as actually better than it was before the fire. Second, I think that wildfire impacts really have to be understood within the context of the housing markets in which they take place. In California, especially, we see these wildfire shocks occurring amidst an ongoing chronic housing crisis in the background. So to this end, any efforts to address wildfire impacts and recovery, I think really also have to consider housing access. Finally, I recognize that my method of snowball sampling very likely biases the sample of people who I'm speaking with. I still think there's value in doing this work, but I additionally think there's a lot of room for survey-based approaches that could better describe relative proportions and representativeness of mobility, but also immobility experiences following the fire. Maybe to leave you all with just a few questions if we have time for discussion. First, I think watching home insurance trends in fire-prone areas is hugely important. And if prices continue to increase so rapidly, especially after moratoria are lifted, and if insurers continue to withdraw coverage from certain fire-prone areas, this could end up functionally evicting many people who can simply no longer pay for higher rates or even find an insurer who's willing to cover them. Finally, unlike hurricanes or most floods, the campfire and other fires increasingly have a legally responsible actor, in this case, PG&E. So I wonder what these massive settlement funds and this legal attribution might mean for mobility policy as we look forward. Thanks so much for your time, and really looking forward to talking with you all.
Thank you, Katie. Breno Braga is up next.
Hi, can you guys see my screen?
Yes.
Yeah, excellent. All right, so thank you very much. I've been learning a lot in this panel, so it's great to be here. So my name is Breno Braga. I'm a researcher at the Urban Institute in DC. And the work I'm going to present today, it's a joint work with Carlos Martín, Vivian Zhang, and Rebecca Marks. They're also my colleagues here at the Urban Institute. So what I'm presenting today is part of a big project that is funded by the National Academy of Science on the impact of climate migrants on receiving communities. So this is a partnership with colleagues from RAND and Enterprise and other institutions. And thus, the goal of this project is the first step is to identify down to the zip code level where migrants are moving after 3 national disasters that I will describe in a little bit. All right. So what I'm going to do today, I'm going to discuss the destination of climate migrants after 3 natural disasters. The first one being the Hurricane Katrina in 2005. The second one, Hurricane Maria in 2017. But also I'm going to discuss the persistent movement of folks in Southeast Louisiana that are being affected by flooding, including the residents of Ile de Charles, who are currently being reallocated to other parts of the counties where they live. As I mentioned, our goal is, for this particular study is to help our colleagues to identify which are the communities that are receiving these climate migrants down to the zip code level. And in order to do that, we're going to use proprietary data, so data that we had to purchase. That gives us a very good, a clear path of where people are migrating to. And more in the future, our goal is to explore different relocation patterns by like the type of climate disaster and things like this. All right, so what we know, and you guys know this better than me, so the US lacks a system of tracking climate migrants. So it's usually hard to quantify where people are moving. So folks have used the census, the American Community Survey. Elizabeth just mentioned the American Housing Survey as well. Other folks have used even social media to track where people are migrating to. But our sense is that the current data often misses key information. For example, it's sometimes hard to differentiate what is permanent versus temporary migration, and like also duration of migration, meaning like if migrants go to a different place, how long they stay there, do they come back to their old location? And also, usually it's hard to get very detailed information on the level of geography where these folks are moving to. So for example, in our case, we really want to go which zip codes folks are migrating to, and that's the goal of the study. So what we did, so we used 2 unique data sets. They are proprietary, as I said, so we had to purchase them, and I'm going to describe them in a little bit. So the first one is called InfoTour, and the second one is a credit bureau data. As I mentioned before, we're going to focus on these 3 disasters, Katrina, Maria, and the Southeast Louisiana flooding. And then what we're going to do is we're going to identify folks that were living in areas that were affected by these disasters 1 month before the disaster happened. And then we're going to follow them to up to 3 years after each of the disasters. And actually, to be honest, in the data, we can follow them for how many years we want. But 3 was the time we decided to use. And as I mentioned before, we know down to the zip code level where folks are migrating to. So where we started, we started with the FEMA individual assistance receipt data. So this was the data just used to identify the areas that were most affected by these 3 national disasters that I mentioned. So using this data, we are actually able to identify the zip codes where folks were living 1 month before each of the disasters. And based on this data, for the Katrina hurricane, we identified 270 zip codes that were folks in Louisiana that were affected by Katrina, And we have these different measures. We have sometimes areas that were affected, but also like the most affected based on like how many people applied for assistance. We also did the same thing with Southeast Louisiana flooding and with Maria. So here is just basically before the disaster happened, where folks were living. And then in the info tour data, as I mentioned before, based on that data, we describe where folks were living 1 month before the disaster. So for Katrina, that would be in July 2005. Southeast Louisiana flooding is harder to establish a date because different from like the hurricanes, that like was a massive natural event that we clearly know what happened. So the flooding in Southeast Louisiana is kind of like a ongoing process, so we have to like pick up a date. So we decided to pick up July 2012. And then, as I mentioned before, so we know where the guys were living just 1 month before the disaster. We know their zip code of location when they were living 1 month before the disaster, and then for 3 years we followed them. And then we are able to actually identify those that stay in the same place they were living before the disaster, and those that like migrate after. And that's what we kind of like show. That's what I'm going to show here. So the first data we use is called InfoTour data. So InfoTour is a company that their goal is to track where people live. So that's actually their main job, based on any information that is publicly available about you. So for example, so death records, or death records is actually not that important here, but let's say your credit bureau information, your property taxes, any public information there is about you that says where you live. The goal of InfoTour is to aggregate that data, and they usually sell that to companies that want to do advertisement. So, you know, like if you want to know, Breno was living in Michigan 5 years ago, but now he's living in DC. So, you know, like let me try to get any public information I have about Breno, so I know he's moving, so I can target, you know, like all the advertisements that I was sending to Breno in Michigan, now I'm going to send to DC. So as I said, this has been used by other companies for advertisements, but researchers are using this more recently. So they actually have data on 260 million adults, and that the data goes back to 30 years ago. So in this data, it's very good because we know exactly the street address where the person lived, and also the dates that the person was living in that particular state is street address, because, you know, like their goal is to say the advertisement there. There is a few limitations with that. So this is just about adults too, let's say that. So there's a few limitations about that. So they just confirm move after multiple sources have confirmed that. So actually the data is not very reliable for more recent years, because, you know, folks are still updating their the public information about their living. So we decided not to use for Maria, because actually when you see that the data doesn't show a lot of people moving yet from Maria based on like the time they need to like confirm a move. But we use that data to track Katrina and Southeast Louisiana migrants. So the second data we use is the credit bureau data. So that's the data that credit bureau agencies use to create a credit score for us. So there's like 3 major companies. So there's like Experian, TransUnion, and Equifax. So we have access to data from one of those 3 companies. We have a 2% nationally representative sample of consumers. That gives us about 5.5 million records. So it's a lot of data. And we have annual data from 2010 to 2020. And it's a refresh panel. So every year we get a refresh of new consumers. And we know zip code of residence of those consumers. So it's a data we can also use to track folks moving over time. So there's a few limitations. So first, this data is only for people that have credit records. So about 11% of American adults are what is called credit invisible. So meaning that they don't have a credit record, either because they are too young, or because they just moved to the country and haven't, you know, started a credit card, or just because they are so poor that they never interacted with mainstream credit system. And also different from InfoTour, this is a sample of records. So it's a 2% sample, not the universe of all adults. And because of the data, we just started getting access to the data in 2010. We cannot say much about Katrina here. So Katrina happened in 2005. But we do use this data to track migrants after the Maria hurricane. So as I said, we have these 3 sites, and then now we're going to see where folks migrated to after the disaster for these 3 sites. So for Maria, we identified 1.69 million adults in the InfoTour data, living in the 270 most affected zip codes in July 2005, so 1 month before the disaster, and about 300,000 are living in the 58 most affected zip codes. When searching for this 1.69 million adults, we find 1.55 million 3 years after the disaster. So, some of them died, and some maybe we just lost track of them, but it's a significant number. And from those that we find in the data in 2008, meaning 3 years after the disaster, 95% of them are still living in Louisiana, and 1.5% of them moved to Texas. As I think it's well known, Harris County, where Houston is the most common destination for those that migrate outside Louisiana. So about 12% of Katrina migrants outside Louisiana moved to Harrison County in Texas. The second most common destinations for a river that is just across the border from Louisiana, and also Texas. So as I said, the good thing about this data is that we can go to very granular destinations. So this is a map of Harris County in Texas. And here we can identify, and each division here is a zip code there. So here we can actually identify which zip codes that we observed, the people that were in a Katrina affected area 1 month before Katrina happened, 3 years later. So you can see that most of them are kind of living in the northwest part of town, and a little bit on the north there too of the county. And that's kind of consistent with what we hear from our partners there, that that's the area where most Katrina migrants move to, and that's being very helpful for us when we want to do qualitative interviews. We know that's where folks are migrated to. For the Southeast Louisiana flooding, we identified 150,000 adults living in the 25 most affected zip codes in July 2012, and almost 3,000 of them were in the most affected zip codes. About 54% of, and then 3 years later, we find 126,000 in the data. So a few of them died or disappeared from the data. And most of them are living in the Terrebonne parish, and 56,000 are living in the Loughran parish, and some of them in other places too. And here's the map where we see the migrants moving. So if folks know well this disaster, most of the disasters happening here, this I think it's where Ile de Charles is. And this is the area where actually the resettlement is. So that's folks are kind of being reallocated to this area. So this is actually consistent with kind of what we expected, that folks are being affected by the flooding are moving to. So finally about Maria. So this, again, Maria, we use the credit bureau data. So this is a sample of folks. So that's why the numbers of people we see in the data is smaller. So the 42,000 we observed in the data in August 2017, so 1 month before the disaster happened. 35,000 are found in the data 3 years later in August 2020. From those, 92% were still living in Puerto Rico, but about 3% of them moved to Florida. Orange County, where Orlando is the most common destination, not surprising. I think we all knew that already. And about 66.2% of all Maria migrants moved to this particular county. And the second most common destination is Osceola County, that is actually very close to Orange County in Central Florida too. And about 5.7% of all Maria migrants that move outside Puerto Rico migrate to this area. What's kind of surprising to me, I was expecting people to be more concentrated in those counties than the 6.2 and 5.7. But it seems it's kind of a well-known that Maria migrants migrated kind of everywhere, like New York, New Jersey, and other places too. But those are the most common destinations as well. And here is the same type of graph. So here's a map of Orange County and Osceola County. So those are the two counties in Central Florida. And you can see that migrants of Maria are kind of concentrated here in the border between there's two counties of Orange County that is in the north and Osceola County. And that's the area where the zip codes where the migrants are more concentrated, and that has been helpful for us for us to do qualitative interviews. So we know that those are the zip codes we should go to interview folks. All right, so just a summary here. We use two kind of unique data to track climate migrants after natural disaster, the InfoTour data and the credit bureau data. We focus here in the three natural disasters that are related to all this big projects. So Katrina, Southeast Louisiana, flood, and Maria. And we are able to identify migrants up to 3 years after they move. But again, we could identify 5 years or whatever years we want because we have information on everybody. And I think different from most data, we actually can go down to the zip code level destination where folks are migrating to. I think that's it. Thank you very much.
Thank you, Breno. And last but not least, we have Matt Hauer.
Can you guys see my screen?
Yeah, you look good.
All right, cool. So this is some work that I was a project I was working on with Valerie Muller, Glenn Sheriff, and Xing Zhang, all at Arizona State, and is now out in environmental research letters. And so what we were looking for in this paper was to model delays for commuters from nuisance flooding in South Florida. And it seems an unlikely fit for a managed retreat conference, but it actually fits very nicely, which I'll explain in just a second. So most sea level rise modeling, migration modeling, uses a bathtub model of inundation, where sort of a certain amount of rise in water level translates into a specific amount of flooding across space, and most of it is related to property values. So like how flooding might relate to property values, or your exposure to hurricane flooding, or just general economic damages due to flooding. And we use inundation, or even just broadly sea level rise, as a stand-in for specific hazards associated with sea level rise and climate change. So the mechanism is very abstract sea level rise, as opposed to very specific, like damages to properties or something very similar. Now, in this work that uses this in the past has four main problems related to it. The first is that it pushes the impacts often very far into the future. So targets for sea level rise are around 2100, and I'm starting to see further papers looking out to 2300 and so on. And so we have impacts already today, which I'll show a nice little video of coastal flooding. The second is that it implies that the mean high water is the actual datum that they use, the vertical datum. And as its name suggests, the mean, that half the time water levels are actually higher. So this is just a real quick example of this. This is the probability of exceeding the mean high water for all the tide stations in the US. And then if we shift it to the right by adding a single foot, like there was a foot of sea level rise. So as you can see, there's quite a bit of exceedance probabilities for most tide stations above their mean high water. So we don't capture that effect. You can't detect any kind of emergent or adaptive behavior in this type of approach, or there's very little in the literature around this. There's some around climate gentrification, but it's not very well developed in this kind of a case. And then it also limits areas to only the hazard area. Like, all right, so your house is losing property value, but what about your neighbors? Or what about somebody that's across the street, or something similar? We don't actually see any kind of actual spillover effects. So we focus on potential sea level rise impacts related to commuting times due to what we call sunny day or nuisance flooding, if you've seen any of this kind of stuff, which I'll show in a second. This great little video right here. And we focus on Miami because Miami has really well documented nuisance flooding. So to do this, we use tide gauge data to measure changes in the person hours of commuting. And so we can look at how this flooding has impacted the historical and the present period. So it changes that from being deep into the future into today. And we can look for the detection of adaptive behavior. So what do I mean by sunny day flooding? Well, this is an example of a nuisance flooding in Miami from a few years ago. I think this was 2 years ago. That is salt water coming up through the drain. And obviously the cars are slowing down to make it through this intersection. This is not associated with a storm. There's no hurricane. There's no precipitation. This is literally just a high tide. Just a high tide. We focus on Miami for a couple reasons. Tidal flooding has increased considerably since 2000. And of course, it's projected to intensify greatly this century. About a quarter of the US population exposed to sea level rise will live in the Miami area. There's limited public transport in Miami, and there's a great deal of data that's available there. So we have three main research questions. What is the current commuting time burden imposed by sea level rise? How have their residents' adaptive behavior affected this burden, which is related to this conference? And then how is future sea level rise likely to affect commuting times, absent further adaptation? So this was a very difficult project to undertake. There was a lot of data that was all over the place to make this happen. But we had three primary data components. We had historic tide gauge data and elevation data. We built a road network, and we used Census Bureau LEHD loads data connecting to figure out where people were going through. So the elevation data is real simple. That just comes from the National Elevation Data Set. The tide data comes from NOAA's Virginia Key Tide Gauge, which has hourly data. And we corrected for extreme water levels due to hurricanes, presuming that people don't actually commute during storm surges. We did this with an outlier detection algorithm. We were looking for areas where, or days where the water heights in the tide gauge data was just extreme, way above what the expected value would be. We're looking at T-scores above 10, and these exactly corresponded to hurricanes Wilma and Irma. So you can see how much elevated those storm surge values were, or the tide gauge values were, compared to what we would think they should have been. It would have really skewed our results. Then we developed a road network in 2019 from a number of different data sources. We got from the Open Data Hub, we got a road network from Miami-Dade County. The Census Bureau also has roads. We got speed limits and what are actual bridges. Those were derived from Florida DOT. And then for any road segment lacking any kind of information, we assumed that the roads were two ways, that they connect at crossing road segments, right? Like they're connected there, and that they have at least a 25-mile-per-hour speed limit. We then took this road data, merged it with the NED to determine the surface elevation of each road segment. So for when the tide gauge would be at a certain height, that road segment would actually flood. Then we used Census Bureau's LEHD loads data for 2002 to 2017, which uses, it's partially synthetic, and it uses IRS data to link up where you live and where you work, presumably that these would be linked in some way. This gives us a very large amount of data in Miami. I think there's 2.6 million unique homework pairs that we end up with. Okay, so with these main data components in place, we could then calculate travel times on our road network between each census block group in Miami-Dade and Broward counties. And we had a travel velocity function based on flood depth. And so it turns out that with up to 1 foot, or about 300 millimeters of water on the road, it's the maximum flood depth before cars begin to float and a road becomes completely impassable. And so based on the amount of water on the roadway, the amount of flooding, we can slow cars down in our routing algorithm. And then we calculate the annual round trip commuting cost for each census block group for each year. So as an example, here's just the travel velocity function. So by 300 millimeters, about 1 foot, that's where we're at the maximum depth and cars begin to float. Okay, so here's with all that in place, we have some interesting results. And I'm going to walk through a very complicated table, step by step. So here's for all homework pairs in Miami, we're looking at 2.8 million pairs, about 1.4 million commuters, and period 1 refers to 2002 to 2004, and period 2 refers to 2015 to 2017. So in period 2, in 2015 to 2017, the average commuter in Miami was delayed by right around 15 and a half minutes. And this is about a minute and a half more than what we measured in period 1 in 2002 to 2004. Now, the thing is that because we have these two periods, we have two changes that can occur. We could have an increase due to tides, right, that are causing additional flooding, but we could also have new commuters as well in these different areas. So that could be driving these changes. You can imagine, right, we have more people, maybe they're living in more adverse areas, and so the commuting times are more elevated. If we hold our period 1 commuters constant and we just change the tide, we end up with an increase of 2 minutes, leading us to assume that accommodation is occurring for about half a minute. Hey, come here. Come here, sit. Come here, sit. It's paused. Sorry, I've got a sick 2-year-old. Come here, come here. Shh, you have to be quiet, though. Accommodation effect of about half a minute. And this is total for the year. It doesn't seem like very much. Shh, thank you. Shh. But it's actually significant if you think about it, that only 2 minutes of increase actually led to a rather significant delay. If we look at anybody who was just affected, the average is about 103. Shh, you have to be quiet. Yeah, of 103 minutes. And again, it was an increase of 6. And we see an even greater accommodation effect. And if we just look at the top ones who are impacted, the top home work pairs, we're looking at 274 minutes of delay and a 20-minute difference because of accommodation. So accommodation is increasing for more affected areas. So again, while these are modest in absolute terms, they're relatively large in reductions. We're looking at, for all commuters, about a 30% reduction. For those who are affected, shh, you have to be quiet, Logan. And 71%. Oh, the joys, right, of modern times. The changes in the distribution is also extreme. This is showing the changes over time between 2002 and 2017. And then also the change in the distribution right here. Shh, okay. And then if we look geographically, we see that they're not really related to any one area, right? Like specifically around the coast, but rather that delays are actually all over Miami. And we see some areas that are very far from the coastline that are most adversely affected as well. Now, one of the amazing things about the LEHD loads data is that it does have some income information. There's not a lot of sociodemographic characteristics, but there is some. This is showing the changes by income groups. There's the loads data has low income, middle income, and high income earners. And this shows the effect that accommodation has on reducing that the delay that it increases between our two time periods. So on the left-hand side of this is in the beginning, right? We have the tide in the first period and commuting in the first period. The dots in the middle show the increase when we have additional tide effects, the additional flooding. And then on the right is the reduction that it has because of accommodation. So who's most likely, or where's most accommodation occurring among all pairs? It's among those who have the highest income, followed by those who are middle income, and low income earners have the least amount of accommodation. We look at the top 5% pairs, it's even more stark. Here we see that most of the accommodation, here all three income groups are actually seeing accommodation, but we see even a reduction among those that are the highest income earners, where their commuting delays in period 2 is actually less than their commuting delays in period 1. So what does this mean for into the future? If we look at sea level rise out to 2060, we see the delay increasing to about 30 minutes for all home work pairs, about 155 minutes for those who are affected, and 140 minutes for those who are in the top 5%. And so this is what it looks like for our distributions. And you can see that in the extreme amount of sea level rise by 2060, we can see a significant amount of delays. So in 2060, the majority of census block groups will face commuting delays that are in the 75th percentile of 2015 to 2017. So what is very common in the future is going to be on the upper end today. So sea level rise is already delaying commuters in Miami, not just in 2100. And that even with a modest increase in commuting, people are already adjusting their work or their homes to adapt to these increased commutes. So we've built this network and we've got a lot of future work planned. One is to expand this nationally, so not just focusing on Miami-Dade and Broward, but to really look everywhere. We've also going to look at how this might impact hospital delays, since E911 service also goes along these flooded routes. We've started to look at impacts on voter turnout, although that's a bit further. And we're also looking to attach this to census data to look at socio-demographic characteristics and climate gentrification. Thanks.
Thanks, Matt. You do a great job of accommodating. All right, well, we just have a few minutes for questions, and I haven't seen any come up in the chat, but maybe Abby, are you fielding any questions?
Yeah, I'll send them to you now. I just sent one.
Okay, great. So I see in some cases, moving a short distance has been as a not great outcome, though it does help with preserving place. For long distance moves, where there are other indicators of positive, negative outcomes. So this is a question, I'm not sure who it's directed to, but I would think it was directed to Jim Elliott. Oh, there.
Yeah, no, thank you for the question. As I think all the presentations pointed out, moving and mobility in these situations is very complex. I'll give you an example of where the short distance move and a buyout can actually be a good outcome, and then maybe an observation on the general trends. You know, in addition to maintaining close community attachments, what we found when we've gone around and looked at what these buyout sites become in different types of neighborhoods, we find that in more affluent neighborhoods, the buyout house oftentimes becomes a pocket park. It's an amenity where kids play. And in fact, what happens is people move just 2 or 3 houses down, elevate, or into a safer space. And then actually homes near those buyout properties in more affluent neighborhoods, next door, when there's a property sign for sale, they actually advertise the fact that this is a bought out property that can never be built again. And even though you would think that might signal a risk, it actually signals an amenity, and back of the envelope calculations suggest anywhere from a 10 to 20% rise, because now you have a park in your neighborhood that you didn't have before where a house was. And that's not the case in less privileged communities where we toured around and looked. Oftentimes those sites, even though the site becomes demolished and therefore possibly an amenity in a pocket park, it oftentimes becomes a site for illegal dumping. You find tires and refrigerators and things that you don't find in those more affluent neighborhoods. Those are some of the anecdotals that suggest, in addition to community attachment, you actually get a preservation and elevation of the economic value of home in those more affluent areas. There's also the more general observation. I don't want to put words into Katie's mouth, and maybe she has some thoughts on this, but in general, when we look from the socio-demographics of the block group from where the buyout happened to where the destination is, overall, there tends to be an increase in the socioeconomic status, whether you measure it in terms of decreasing percentages of poverty in the neighborhood or elevated incomes on average, et cetera. So in general, people seem to be not just moving from the flood risk, but also what we might call moving to improve. If it allows them to actualize an increase in their neighborhood status, which probably goes along with better public services and whatnot, that enters into the mix as well. But I agree, there's a lot of heterogeneity in there, but even with that heterogeneity, we're seeing these patterns of different types of retreat that seem to disadvantage the accumulation of social capital in these lower income and communities of color.
Katie, do you want to comment on that? Have you seen that too? I mean, is that how you would interpret your finding?
That's a good question. I have not looked at the larger demographic characteristics of the places that the folks I've interviewed are moving to, so much as ask them about their own situations. Certainly talk to folks who have improved their situations financially by moving. I think the way I think about responding to this question is more along the lines of mental health. A lot of the folks that I interview, I don't ask about this, but almost everyone brings up stress, anxiety, post-traumatic stress that they still experience because of the fire, and that managing that in some ways I think is harder, being in a community surrounded by other people who they don't necessarily know, they're no longer part of their community, and there's not this shared experience of trauma that many describe. And I think this is definitely a negative outcome for those who've moved.
Yeah. All right, we have another question for Matt. Matt, do you think it is possible to extrapolate accommodation into the future as well in terms of changes in commutes and where people live? I was wondering the same thing when I saw your projections.
Yeah. So there's a good thing and bad thing in the LEHD data. We know where people live and we know where they work, but we don't know the individual. We have the counts. We don't know the individuals, right? So we can see that different home work pairs are waxing and waning, right? They're either more or fewer people along those routes, and we know the routes that have the greatest amount of delay. And so it turns out that as areas flood, that people are done. It seems to be they're adjusting either where their home is located or where their work is located, or possibly even both. In the historic period, where the delays are relatively modest, like 15 minutes summed over the whole year, right? Not like per day, is relatively small. But as we go out to 2060, those small delays actually become very large, and we no longer have areas that are unaffected, basically, right? That people could move into or out of. So there's probably going to be a limit to the accommodation that places like Miami can actually experience, or at least this sort of like, dynamic adjustment. But there's nothing yet in the historic period to show that limit is. So we could probably do that for low amounts of sea level rise and even possibly intermediate. But for extreme, it's like there's nowhere else to go in Miami if we have the upper end amount of sea level rise.
All right, well, that brings us to the end of our session. And I want to just thank all of the presenters for their presentations today. I really feel like compared to the last managed retreat meeting, we really seen a lot of advances in terms of understanding social disparities in climate change impacts. And I'm really pleased to see that. I think social scientists have a really important role to play in this conversation, and we now have more data to do that and more methods that were really well demonstrated here. So thank you, everyone, and I look forward to seeing you in another session or next time.
Thanks, everyone.
Thank you. Bye-bye.
Thanks so much.
Bye.
Nice to see you all.